Today I'm going to describe the SMAP flotation system that I've been using here in Chiripa, Bolivia for many years now, with some modifications over the years based on other archaeological research on flotation systems. As you're aware, water flotation is useful to separate out fragile things, small things, and especially for an archaeobotanist, the plant remains, the charred plant remains that are almost completely hidden during excavation. This system has been in operation since Patty Jo Watson first published it in 1976, working in the Midwest of the United States, but many people around the world have been using it. It's slightly different from what's called the Shirov system, which uses a mesh inside the main drum. But in the SMAP system, we use an interior bucket that we take in and out, which I will display in detail so that someone watching this hopefully can not only reconstruct this, but also learn the key elements of flotation. Before we actually start floating and showing you the complete process, I'd like to show you the pieces of equipment that this system is made up of. First of all, the original system starts with a metal drum, 55-gallon drum, that is then adjusted to be able to have water enter. You can see this coming in, you'll see it more later, entering into the system, and inside you will see a shower head, essentially. This is actually a Primus stove that I punched holes in because Gordon Hillman told me to make a nice big shower head and I couldn't find one. And then there are these bars that hold the inner bucket, as I said. There is a mouth that is welded on with hooks. We try and stop the water with this, and then we put this inner bucket in there. But first I want to show you, this also is a drum that is adjusted. It has a very fine 0.5 mesh. You can go to 0.3 millimeter mesh. Some people do that. And it also has this long mouth as well, so that it can come into this reel and sit inside, push forward, and ready to go snug once this is filled with water. The other pieces of equipment we use, of course, is capturing the light fraction that floats. And for this system, we've shifted from geological screens, which Patty Jo Watson did originally, to a very fine 0.15 mesh that we put into a bucket that also has a mesh to capture anything for overflow that we clip on. We actually use a magnet on this side so that the clips don't get in the way, and it ends up, you will see later when we're operating, it ends up receiving the water perfectly in here. While we're floating, we also use T-strainers to capture material that's not rising to the surface through the circulation of the water. And the other thing that we use that was published some years ago is a siphon that's very simple. We've had to clean it up a little bit, secure it, and you'll see later this demonstrating where we put it down very low in the water to collect anything that's low, that's not rising up, that's just circulating. So the system of water flotation essentially cleans the bag of dirt. In this case, we are shooting for 10 liters, which we will measure in a minute. And then as we're cleaning, we shake the soil, we stir it gently to help clean all the material that's in the bottom, the heavy fraction, but also allow all the carbon material to exit and float into here, which we then can dry and take back to the laboratory and analyze. Occasionally we get heavy carbon that sinks to the bottom, that stays in the bottom, that may be still attached to some dirt or is particularly large. But usually the heavy fraction are the lithics, ceramics, a lot of bone in this case, and beads, other things that you can't see in the normal screen of excavation, but you see beautifully in the heavy fraction, which we'll look at later.